Hi guys, I'm Shuan. Today, let me and my team share about the use of supercritical fluid technology in biodiesel production. Biodiesel are not only good for the environment, it could also extend the life of diesel engines because it has more lubrication than of petroleum diesel fluid. To produce biodiesel, transesterification is the main reaction. It is a reaction process that produces fatty acid, alkyl ester, our biodiesel, and glycerol by achieving an equilibrium reaction between triglycerides and alcohol. The alkoxyl group of triglycerides and alcohol would switch to form the ester compound. Bioethanol, as one of the examples of triglycerides, has high viscosity and low volatility, which is not suitable for a diesel engine. It will cause injector choking and carbon deposit in diesel engines. Therefore, through transesterification, the viscosity of vegetable oils could be reduced to a value that is very similar of a conventional diesel. Now, let my friend here, Bo, explain more on the general process of biofuel production through supercritical fluid technology.
The process is carried out in a pilot plant with ethanol of 99.99% purity and vegetable oil as raw material. Ethanol is fed at 20 degrees Celsius while vegetable oil is fed at 40 degrees Celsius at 1 to 100 alcohol to oil molar ratio with equal flow rate of 15 liters per hour. The alcohol oil mixture is compressed by pressure pump before feeding into the static mixer. Then it enters a series of heat exchanger for heating, which is where the reaction takes place. It first enters the preheater of E102A, which is heated by heater E104 and regulated by closed loop regulation unit PU102. The reaction happens in R101 at temperature ranging between 250 degrees Celsius to 400 degrees Celsius at a pressure between 150 to 250 bar. Coming out from the reactor, the fluid is cooled down by heat exchanger E102B. Then it is passed to E103 for further cooling down to 60 degrees Celsius. After cooling down, the fluid is separated by decanter centrifuge since the product contains two phases. Biofuel, which is the product, and glycerol, the byproduct of this process, is then separated at a final temperature of 25 degrees Celsius.
Safety is one of the important issues in this system. In this system, there are several safety precautions has been done to prevent accident happen and obtain the desired product. In this system, a total of 11 bleed valve is being used. Bleed valve has a function to extract samples at certain point of the system for checking purposes. Another valve, which is ball valve, is being used in all the subsystems, which is for maintenance purposes when any problem detected. Then there's a closed loop control unit, temperature transmitter, temperature indicator and controller, and temperature controlling valve is being used. These sensors and valves are being used to ensure that the system is running and the reactors are reacting under good condition. Besides, SiC is being used in the reactor to reduce phase segregation effect and preferential path. Lastly, after the oil-alcohol mixture passes through the reactor, a pressure rupture disc is being used. It is a non-reclosing pressure relief device. It has a function to protect the system from overpressuring or damage from vacuum conditions.
Throughout the whole process, the desired conditions for each process unit are maintained and regulated by the feedback and feed-forward control system. Most modern control systems utilize instruments and measuring the process output variable and manipulate the input variable, which is the feedback control. In this transesterification process, three control systems are introduced to three nodes: heat exchanger system, cooling water system, and separation system. In the heat exchanger system, the temperature of the inlet fluid is measured and the temperature transmitter converts the measured variable to a standardized signal and transmit it to the temperature indicator and controller. The controller then controls the temperature control valve to regulate the temperature of the fluid using cooling water. The same control system is applied to inlet fluid of the separation system, where the pressure of the pipe is regulated using pressure transmitter, pressure indicator and controller, and pressure controlling valve. On the other hand, the cooling water system controls the inlet temperature by measuring the outlet fluid temperature. In the heat exchanger system and separation system, the control system is a feed-forward control. whereas the control for cooling water system is a feedback control. The reason why feed-forward is chosen for heat exchanger system and separation system is because the feedback is easily affected by unpredictable variables, and this will cause the system to shut down. Feed-forward can anticipate changes and react positively. For cooling system, when no reaction is taking place, the cheaper and simpler feedback control system is used.
In the reaction of transesterification of triglycerides with an alcohol, ethanol is used instead of methanol. Generally, methanol is known to be a better choice due to its high reactivity and low cost compared to ethanol. The reason why this process uses ethanol is because the less reactive alcohol is a renewable fuel, which can be extracted from vegetable oils and bio-derived methanol. Methanol comes from fossil fuel which is non-renewable. The aim of this process is to produce fully renewable fuel. Besides, methanol is highly toxic to humans, and the vapors of methanol are irritating to the lungs, whereas ethanol is less toxic to humans. Furthermore, the process is carried out in supercritical fluid instead of the conventional alkali catalyst method, which produces large volume of wastewater and feedstock flexibility. In other cases, transesterification using acid catalyst may lead to formation of undesirable byproduct, and it is difficult to separate. Therefore, the process uses catalyst-free technique of carrying out the transesterification under supercritical conditions. This will not only maintain the benefits of the biofuel without compromising the environmental concerns, but also introduces the use of green technology to the world.